Okay, hi everybody. It looks like we're right at 11 o'clock now, so we'll go ahead and get started. Welcome to the second seminar in the FireLab's Spring 2021 seminar series. Today we have Joaquin Ramirez as our speaker. So Joaquin has a bachelor's in forestry from the Polytechnical University of Madrid, a master's in forestry science from the University of Lleida, and a PhD from the University of León in Spain. He's the founder of Silva, which was founded in Spain in 1997 and then expanded to the US and San Diego in 2012. He's also a professor of geotechnologies and wildland fire and emergency management at the University of León, and he's a member of the board of directors of the International Association of Wildland Fire. And so with that, Joaquin, I think I'm just going to hand it over to you. It's all yours.
Thank you, Natalie. Thanks everybody for joining us to one of the numerous web meetings that we have nowadays. I hope everybody's safe. So yeah, and hope everybody took their coffee in the morning here in the US, and it's anyone is in Europe. In Europe time is not, it hasn't been a long day because this is going to be fast and intense. Thank you so much for the opportunity. This is the agenda. This is what I'm trying to talk about today. We're going to make just an introduction of our role as technologists and who we are, some of the collaborations that we're already doing with the FireLab. We'll also talk a little about the kind of the applied research and development that we try to do in collaboration with other researchers and trying to, fill the gaps that we find that are needed to just give answers to our users. And then we'll show the technologies that we developed and the tool that we created to support this user community that is really guiding and is our motto on all these 24 years that I've been working in this arena. And then if we get there, hopefully we'll just go through a demo. I wanna start with this slide because it was in 2008 that I did the first trip to the lab with Marc Castellnou and a group of Catalonian members of the GRAB team, and we were graciously hosted by Marc and all of you, and you did what you always do, and it's just making the science advance and then sharing and showing and being really an inspiration and a support to all the work that we try to do as technologists. So really thank you for that. After that, I just met many of you, just got introduced me to many of you, then I met Matt, some others, we'll show examples, but everything really started to have a solid foundation when I met the lab. So really, as you can imagine, for me, it's a thrilling moment. That was 12 years ago, and now here we are. All right, so for the ones who don't know Silva, just I'll let you know a little. Now we are a group of about 50 specialists, around 40 in Spain, 10 in the US. Today, my presentation has been supported by our chief scientist, Santiago Monedero, Adrián Cardil as a senior researcher. I'll show some work of Akshak Chulawat, who's working on the WUI. I'm back, and David Buckley back, and David Jones, always supporting all the how we get to the users at the end. But as I mentioned, part of my team is in Spain, and we have a wonderful place in León, and that's where we have a ton of scientists, GIS specialists, foresters, and developers that are making these things possible. Okay. So who we are basically, I like to, we are fire people, so we love triangles, right? So let's talk about a little the triangles that I see. It's what is the role of our fire technologies? We are fire technologies. We are trying to really understand the science that you guys scientists are creating in the lab and some other academic institutions. Try to understand that, and you also try to understand the users to try to create applications that really help them to, in their hands, improve their processes. So it's a work that we have. I always felt that the three pieces are together. It's not scientists only working directly with the users. Something is missing there. I think that we try to make those that science operational, and that's what we try to do. Is that trying to make that science operational and help the users to improve their organizations, their missions, making it safer. No, so going from calculations and models to integrated tools that really deliver in real time in the demanding scenario that is the wildland fire. It's I used to say that it's more demanding than the war because we don't have a red button, but we have all the complexity of the modeling in wildland terrains with the interaction of weather, complex interaction of weather, ecology, social factors, etc. So it's kind of challenging to deliver in that environment, and that's what we try to do. Also, I would like to say, when we talk about a little about modeling, I also like to talk about this operational technology triangle, OTT. There is composed also through three parts. We try to do operational solutions. We have to be able to work with operational models that should be battle-proof, tested, accepted, and trained to the community so they can embrace it and really rely on the results of those models. Also, those models has to be fed with data, and we need to ingest a ton of data. And as I mentioned, it's observations of fire, tracking resources, weather, conditions of the phenology of the plants, a ton of information that has to integrate it and has to be delivered in the right amount. We cannot infoxicate to our users, and we have to deliver what they really need, because it's their environment that they have is too much. Sometimes it's as bad as too little, okay? So that's what we're trying to do since we started. As I mentioned, we started in Spain 1997, 24 years ago. We created our first computer-aided dispatch wildland fire system. It was based on our View 3. That's was a technology that we thought that taking decisions on dispatching resources, you really need GIS information. So we integrated the first Landsat imagery, and we tried to deliver it in a simple interface. Then fast forward a little, then we started to work with more advanced organizations like the Andalusia government, and they were embracing the ICS, and they needed tools that were able to just moving from dispatching to incident operations and incident support. So we created the tools to support, 204, 207, all the organization on the incident, and make it connected with the GIS and the dispatching, right? Then fast forward again, that's when we came to the US with this product, with FireResponse. In this case, we started to work and support our champion in the South, the Texas Forest Service. They came after the 2011 worst fire year in the history. It was also another 4 million acres like this year in California. So there we extended the FireResponse into making, resource management, tracking resources, tracking qualifications, rostering resources, lineups, and doing the dispatching with real-time tracking of the units in the field. And that's what we've been doing in the South for now. It's 7 years. A little fast forward, we share with the community our tribute to the lab. To be honest, this Wildfire Analyst project now it has about 10,000 users in the world. And it's a very simple tool that just tries to open the conversation in the field about quantitative look at fire behavior. We'll try to improve it and extend it a little, but the reality is that we're getting a ton of very positive feedback, because it really gives, puts the complexity of calculations in a simple way that it's actually what is demanded by the community right now, right? And then I talk about a little the collaboration with the lab, and I think that we've been so fortunate to work with many of you there. With Mike Jolie, we were able to deliver this year. He's made a wonderful job on explaining and sharing to the community how the WAFs and the new severe fire weather indexes and all the work that he's done with all the climatology related to wildland fire, how it is offered in a very simple and I think pretty appealing tool, Wildfire Safe. Unfortunately, we could be delivered on time for this fire season. That's been really fantastic. And we're also working with Matt in some other topics related with plants phenology. Something that was really very close to me was being able to work with Brett Butler. I came here in 2013, definitely in the US, just 4 days after the Yarnell fire. So for me, it was really a great motivation to be able to work with Brett on the safety zones model, and now together with Phil Denison and Mickey Thompson on the escape routes models that are going to be just a simple app that's going to be in hands of the people of the field. Natalie, sorry, but it's been also a fantastic collaboration with Natalie and with Jason and with Brett on the Wind Ninja app. We were able to update the Wind Ninja app, and we're really excited to also to support the development of the fire weather alerting system. We definitely think that understanding the wind, the way in an operational way, obviously there are more complex systems, but definitely nothing. I think that nothing so elegant and so productive as the Wind Ninja app, and it was another example of collaboration. And also getting the feedback and collaborating in individual studies, like for example this Dolan fire entrapment that we did this. Working with the feedback from Natalie, we just did some analysis for her to just be able to validate and compare the different sources of data like National Guard, fire modeling, weather conditions, and hotspots. So really excited to see the models working in action. This picture of the King Cape fire, I don't wanna. I also want to raise that for us it's very important to work with academic institutions, and especially with San Jose State and all the team of Craig Clements is putting together with Adam Kochansky. They are really an outstanding center in terms of training and research, and we are really excited to be working with them in the next generation of couple modeling. So that was kind of the intro. I think hopefully it wasn't too fast. So if there are no issues, I'm going to jump to the second part. I'm going to present a little of our applied research and development. And obviously, I think that the camera is totally off. Maybe better now. All right. So obviously, we're a small company. Thanks to being able to grow in the last 5 years with the support, we had a big support from San Diego Gas and Electric at the beginning, because to be honest, this is a small world. There were not too many technology companies out there because the reality is that there was not a market. Everything exploded after the campfire, but before that, we were a little team. We were doing what we could in terms of publishing in collaboration with other researchers or our own team. But that has changed in the last years, and we started to publish recently. Just show some of the lines of work that we did. For example, something that we started to do in 2014 was working with Kristen Allison, one of the US Forest Service on re-initializing our wildfire analysis modeling with satellite hotspots, and then we did a paper after that. Also, after what happened in Santa Rosa in 2017, we had a model that is an exposure analysis, this kind of fire sheds or dynamic fire sheds or exposure sheds. We think that they're really very useful way to apply the modeling in an inverse way. So that could be done for the communities in advance and to support preparedness and support evacuation planning and support community outreach. And we did that paper on that. And also, although we already have our calibrated automatic calibration of the rate of spread equation from the Rothermel equation, we have done it in some other equations. What we call it the Rothermel hammer, it is gonna fit to the observations. We finally published the paper on that. I have just a little example, but basically the idea is that try to minimize the errors between the observations and the predictions, and just calculate the adjustment factors automatically. We do that like in seconds. In this example here, we have a 3 hours fire. There's going to be some observations that tell us that the fire actually got to some points a little earlier. I think it's I'm going to fast forward in 1 hour. All those points is instead of 2 hours, it's 1 hour. So the algorithm calculates and adjusts on the fly, and then goes creating continuous simulations based on those adjustments, and those adjustments can be analyzed later, right? An evolution of this is now, I'm going to show a little of the new lines of work is how can we, based on observations, that the work that we did in 2011, how can we improve it based on the new techniques and tools that we have available right now? And Santiago Monedero started to work with, trying to think how can we improve operational models. As I used to say, we're model agnostic. We don't care. In Chile, we're using the Kitra model. Here we're using the Rothermel, we can use the MacArthur. A new model comes, we'll do it better. But the actual machine learning and deep learning algorithms can help, if you have the right amount of information, can help to improve basically any model. So what happened is that this fire season, for the first time ever, we had all the data that could match and could explain the fire behavior equations together with an unprecedented amount of observations. As you know, we had the worst fire season recorded in history in terms of size and intensity, about 4 million acres, 4 to 3 million acres burned in California this year. For all of those fires, we had observations coming from VIRRS and MODIS, but also we had observations, we'll see later, from other sensors, I'll show later. So basically what we do is we clusterize the data. We have a couple of methods to do that. We calculate the time of arrival in a continuous way. Both methods have some pros and cons. And then we calculate the spread vectors for every point of those polygons. And to all of those spread vectors, we apply or we assign all the fuels, winds, fuel moisture, observations of the fire, etc. All that together with all those variables. So we can compare the observed rate of spread versus the expected rate of the spread, right? And this is, you'll see some more of this, but this fire season was also quite unique for us, because I used to say in my presentations in the past, in my classes, is that we used to fight fires without knowing what the firefighters are and without knowing what the fire is. Well, this year that has changed. With the collaboration of the Region 5 and CAL FIRE and the National Guard, we've been able to access to more than 500 fires with fire perimeters every 15 minutes in real time. That's absolutely unprecedented. So that amount of data, obviously, it's if you combine with all the inputs that we have for the fire behavior modeling, is absolutely unique. So we have applied these methods, and what we try to do is try to combine both, try to calculate the spread of all of them, and try to find where the actual models don't fit. We don't know that the actual models underpredict or overpredict or don't perform. In some cases, we have a ton of cases that they work pretty well, okay? So the idea is, okay, well, let's try to put some numbers of what we don't know and try to focus the new models or the new answers that we want to apply in using these kind of techniques, okay? The last research that I would like to, that's another topic that I would like to talk about. This is about WUI and vulnerability modeling. That's this award that is being led by Akshat Churawat, who did a paper in Nature about his new graph-based WUI model at the individual building level. Basically, we focus in this arena because first, there are not WUI models out there that are operational, right? So we thought that it was operational, and Akshat is leading this effort with the Technosilva team. Basically, it's what Akshat is doing is trying to calculate the different parts, the combination of probability of ignition due to 3 heat transfer modes: convection, radiation, and ember spotting. What we get is not a spread in time. What we get is a probability of ignition, and that could be calculated in advance in different scenarios. We can calculate which are the most probable paths that in a community, in certain conditions, the fire can go through all the surrounding vegetation, all the vegetation at the macro scale, and from building to building, applying a combination of algorithms that are here, okay? So basically, that we're applying that right now. We have a great data set that is coming also from CAL FIRE, the DINS data set to test the model. And we have a great source of data that is all the inspection buildings and all the high resolution fields that I'll tell a little. So hopefully we'll get to some results to improve our actual, what we think actually is still the best way to do modeling on the interface, which is our fire encroachment algorithm. I'll tell a little about that. Last part I'd like to talk is about fuels. Fuels obviously are absolutely critical. We have to face, when we just blame the models that they don't work, okay, garbage in, garbage out, right? The reality is that to go into operational decisions, we spend a ton of money on weather models that give us every 2 kilometers the best potential conditions of the weather. But regarding the vegetation, and especially in dynamic environments where the problems are bigger, like California, Spain, Chile, Australia, typically the vegetation maps just are updated, if we're lucky, between 2, 3, 4 years, right? Well, when we provide a service, we need to be focused. As I mentioned at the beginning, the data has to be the best possible and reliable. So we're doing that work in California, in some other places in the world. We started in Spain, then we started Camp Pendleton, Angeles National Forest, and then we scale it up to California. So for this, we're working with different sources of data. We're updating these fuels every 2 months. We have an update at the beginning of fire season, then we have a monthly update during the fire season, and then we get ready for the next fire season just before. Updating the weather every day and updating the fuels every 4 years, it makes no sense, right? And especially when, for example, for 4 million acres burn our area, right? So, okay, we integrate all this data. Obviously, there's a wonderful sources of data, and one that is dramatically new is all the LiDAR data. We're working with well, I'll show a little about that. Also, what we thought is that we needed to explain, be able to evaluate the fire behavior and the potential exposure in the WUI. So we expanded the non-burnable categories on the original 40 fields from Josh Scott and Bob Borgan. We expanded all the 91s categories, the 90s, into different categories that display and can help us to do a better job on the potential urban encroachment. Like, for example, with a combination of urban density, houses density, and vegetation surrounding, right? So as I mentioned, we update every month with before the fire season, after the fire season. Our team is calculating with Sentinel DMVRs, so we can apply different evolution of vegetation, obviously not during the fire season, but for the years after. And I also would like to talk about our work on LiDAR. So on LiDAR, as in Spain, we started to work a lot with the LiDAR because the Spanish government made a wonderful program. The PNO, I think it started like 15 years ago. We have LiDAR all over the Spain, so we're pretty used to work with this. So we run all the processing in California, and we have created a model. Dr. Adrian Cardil is making a model to try to populate all the canopy fuels on areas with LiDAR and with areas with no LiDAR available. That's pretty exciting. Actually, the results are really very promising. Last two things, Moody Life Fuel Moisture model based on machine learning and several variables, and with the available data set that is coming from the National Fuel Moisture database. We have created a model because we needed live fuel moisture in a continuous way all over the landscape. And we do that product is created weekly with a 250 meters pixel resolution, and the same for their bases. Okay. All right. So I think that now we're going to go through some of the technology applications that we have created. At the end, as I mentioned, we're a small company. To make the technology sustainable and to provide an answer to such a complex community, we have two options. One is go and ask to the customers, what do you need? And we build it. And then thanks to the 24 years of experience, and really, I think that the best thing that we try to do is to listen and to analyze what you guys tell us, what the community tell us, and what the science community tell us that is possible. Try to package and to try to make tools that are sustainable, and they have to be products. What I mean by a product is something that has to be applicable in many places, that we can have a team to support the evolution, to be up to speed with the technology. We cannot make anymore just one-shot projects that is not going to help us to, it's going to keep the pace with the technology. As you know, the technology now is terrible. So these are the three products that we have developed. Fire Response is a full incident management and dispatching system. Wildfire Analyst is our modeling framework. And Tactical Analysis is the tool to work at the individual incident level with the data simulation, with real-time resource tracking, etc. So let's take a look just a little briefly on Fire Response. Fire Response started to be used many agencies in Europe and in Chile, but it's, in the US, we started in Texas. Now it's the incident management system for Texas and all these states in the South. One of the modules of tactical analysis is being used in California, replacing the actual scout, which is the tactical analysis, all the operational on one incident. As I mentioned, it's something that we started to work in 1997, and we created the first mobile tool in 2005 with our part technology. It started to track resources in 2007. We integrated in runtime technology in 2014. We were one of the first CAS to be integrated into the Irwin system, and actually the Irwin system got our resources model to extend the model to what is right now the new standard on Irwin. And we made it mobile in any platform. There are some states like Virginia that is starting to use mobile first. And this year we have a ton of exciting improvements on modules like the burn permit that is going to be used in Georgia and in Florida, burn permits Wonderland. Managing multi-activities, not only fires and multi-hazard that was in the past, but also forest activities that could be done or tracked before the fire season. Super preparedness, and we have now a very tight integration with all the area environment. Okay, I'm going to jump into the platform. You will see that all our platforms are web, desktop, and mobile. It's a very complex environment, the one that we have. You cannot make a tool that works for all. You cannot make a tool that is only web. How do you support the field if you do it only web? It doesn't work. You have to do something that is disconnected. So I'm going to show just a little the interface of the fire response. That's the tactical analysis part of it. Very simple. It has to be really quick to be learned. It's a tool that is in 1 hour. You have all the training that you need, and it's used in 1 minute. That's something that I learned also in the lab. All the incident mapping, all the incident information, pictures, log, all the dispatching and tracking resources in a very simple and neat interface, but also we need it in the field. So in the field, we have a specific mobile tool that is fat finger technology, as you can see, very clear. Just in the first screen, the firefighter has all the information that they need. What is the incidents? What is my incident? And they can have the information like getting to the incident, all the weather, taking photos, incident action plans, disconnected mapping. We don't use GeoPDFs, sorry, that's a thing of the past. We have all California in one file, it's 40 gigabytes in one file, and that's it, you go disconnected anywhere, and all the mapping is a tiny package that it goes disconnected with you when you do it, okay? So very simple to use, as I mentioned. The interface, it's really focused on the firefighter on the field to get information, but also to provide information to everybody at the incident level. So from the field, you are mapping and you're sharing the information, as I can share here by the finger with the GPS, and following all the NWCG standards. And when the information is ready to be delivered and you have connectivity, it will sync for you, right? Other examples. Again, as I mentioned, you need 3 platforms for this. And I'm gonna just present a little the wildfire analysis, which is our advanced real-time fire behavior framework. Maybe some of you know the wildfire analysis desktop, that we have different versions. For example, in Chile, as I mentioned, we use the Glitteral model. In Spain, we have different flavors, but basically it was a desktop-based tool that was disconnected, more focused for the advanced. Part of the family were the mobile pocket. This project started in 2007. This product, it was funded by an European Research and Development project. We created initially as an RMAC extension on our GIS, but then it went growing. We introduced the new simulation modes in 2011, the calibration of simulation mode, the adjust mode, exposure analysis, reverse in time simulations, and probabilistic. All of them were developed in 2011 and used by the advanced community. We have about 200 advanced all over the world using it. Then we started to work in real time for the environments. That we got the support from SDG&E, and we could develop this environment. Then we went into supercomputing. We started to run millions of simulations daily. We started to introduce the LiDAR fuels, and we moved from the static risk to daily real-time risk modeling. We integrated with Irwin, we integrated with other wildfire cameras, and we went into production with Cal Fire Altoids based on that. And we'll, in the future, and what is coming in the future, I think that we've seen a little. So I'm going to explain a little of this tool because it was selected in California as a technology solution in after the 2018. there was a request for an innovative ideas of Governor Newsom, and he said, okay, well, we're going to do the things in a different way. We are in California, we are, Silicon Valley is here, the best universities are here, or one of the best. Let's tell to this community what we need, and you tell us what you can do. And that's what we did. There was 2 questions, early wildfire detection. That was, in the end, that wasn't done, and actually it's been done, replaced by the National Guard. And the second request, that's the one that we were selected, is the prediction of wildfire path and daily dynamic risk, okay? We're selected amongst 131 companies. Everybody was there, all the Silicon Valley companies that you can imagine, universities, research center, and okay, we were selected and we were tested for 4 months. We spent 4 months from October to November being evaluated, and then we were selected. We have a 3 years contract with an optional extra 2 to start statewide just before this FireCast season, right? Okay, so what is the solution? This is the evolution that we started to do for the utilities in the past, and the evolution of the wildfire analysis. We call it Wildfire Analytics Enterprise. It has a couple of functionalities embedded in this Wildfire Analytics Enterprise and different platforms. One is what we call a FireCast, which is, a FireCast, which is hourly, actually it's every 3 hours, wildfire risk forecast and monitoring for the next 4 days. It could be extended, but we're just doing 4 days right now because we're using a specific weather model that give us that horizon. And also FireSim, which is the on-demand spread predictions, okay? That, again, it can be displayed, web, mobile, and desktop. So let's see, basically everything starts with our capability to implement fire behavior models, integrate the data, and produce results in seconds. Actually, you'll see in action, but in just a regular computer, we can get a typical spread simulation with all the outputs that are needed for an analyst to evaluate it in about 10, 15 seconds. It depends on the size, right? This is an example of what we see. We have created a 4-dimensional environment. It's an environment of 3D plus time, because that's how you can explain the fire. It's dynamic. We need this. I know that maybe Florida and Texas are a little more flat, but man, in Colorado and in the West, we need the mountains. And in Spain, we didn't need the mountains. So yeah, I think it's the way to go. We are using every runtime environment. It absolutely performs. We really need that kind of reliability on our tools, and we have a great collaboration with everything that they get new. We just get it. We have a great integration of the data. And for example, this is the integration of the impacts to population and people. That is also created automatically in 10 seconds, right? Any individual building that is in the US or whatever is data set, individual infrastructure, everything is there. And we started to do this, as I mentioned, in 2017, right? Another real important thing is the integration of this information on the dispatch, okay? As soon as we have a fire, we're creating automatically the immediate evaluation of the incoming alerts. So in 10 seconds, as soon as it gets to the cab, any firefighter on the field could have that information in their hands and just provide the feedback to improve that simulation. Because as we will see, one of the biggest problems that we have is the location of the incidents, right? So that's critical. And we assign an initial attack assessment index to any individual fire. This initial attack assessment index that we have created, it's a combination of fire behavior and a combination of potential growth of that fire. We want to simplify, if possible, what is the potential growth of that fire and what is the potential difficulty in suppression for that fire from the get-go, okay? So we have a 1, it's a fire that the fire spread is not very large. 5, it has potential many impacts, it can grow a lot, it has a string fire behavior, okay? And we do that for any one of them, right? Another important thing is in the integration of different sources of information, like picture from the field, from the mobile photos from our users that are using fire response or wildfire mobile, the National Guard fire perimeters, or the alert wildfire cameras, or any source of data that you can imagine, and we'll show some examples of what is coming is there, right? Also, we calculate every day the risk forecast based on individual ignitions in a regular grid. Actually, we're using our grid that is based on, is based on an hexagonal center grids. We're making about 144 million simulations every day, every 3 hours. We start 8 hours fires for the next 4 days, okay? And then based on that, we combine all of that in different kind of outputs, and that's what becomes the forecast. In a year, we've estimated that we made over 50 billion simulations, and this fire season were already over 30 just for Cal Fire. We've done that also for the utility, just multiplied by 3. So we're about the 100 billions just this year. It's a ton of modeling. So the models could be wrong, but we are definitely consistently wrong. We do it a lot, okay? This is just an example. We include size of the fire, flame length, fire volume, rate of spread, ground fire potential, but also impacts like buildings, population, all the impact analysis. And all that information is shared by the units of Cal Fire every day to support potential dispatching levels or setting up preparedness levels, okay? These tools have been tested during the fire season, as I mentioned, and as we summarize this information by unit, this fire season, we evaluated that the worst days that happened during this fire season were absolutely predicted and detected by the FireCast. We have the peak that we had in the October event, okay? Another example of the integration is the integration with the FireGuard. This is a simulation, automatic simulation together with the FireGuard integration. This is what is feeding our next gen of the, how we want to empower the actual models, whether it's whatever we have, it's Rothermel, the Canadian, we don't care. But if we have observations, we can do this, and we have observations with the FireGuard. That's an incredible gift to the community that we have right now. We are tracking the incidents for the first time, real time. This is, I think this was the cruise fire actually, yeah. Also, as I mentioned, everything is available in the field. That was the Kincaid fire. We ran the simulation. We had it in the field with Craig Clements, and boom, there we have the results that we can evaluate and test. And for example, say, you know what, the fire is not here, right? And also the live feed of, for example, this is something that I'm really very excited. This is new for this fire season. The integration of drones and the integration of aerial footage for aircrafts. Here we can see is the Corning Aviation videos that we were captured this fire season. In this case, this was the Clermont fire, where without integration, the users get access to the video that is coming from the camera from the plane. It is integrated, and as you can see, I'm drawing in the picture in the video, and that's appearing in the map. And I'm putting my finger in my screen, if you could see it. It should be something like this, right? And also I could draw in the map and it will appear in the video. It's pretty, I think it's a pretty neat integration. And also what is pretty neat is that it's done with drones. So you can do for the first time with a DJI drone or whatever drone, the $500 drone, you can fly it. I know that we cannot fly them flyers, but we're gonna start with prescribed burns. Hopefully in the future we can. And get the footage for the drone directly into wildfire analysis and the tactical tool. So you can have like a very cheap aerial platform in any incidents, like in seconds, okay? All right, some numbers, results. This fire season, there were like 12,000, close to 12,000 individual simulations. There were about close to 8,000 airwind incidents that were evaluated, 3,000 live fire season, 270 from the FireGuard. We also calculate automatic simulation from the FireGuards, and that close to 30 billion simulations from July 1st, so it's a ton of modeling. I think that one of the important things that we do in this platform is improving the data and the method. So it's about integration. This is like an integration of good food. That's a Spanish paella with technologies. That's what we do. Get good pieces together, try to provide that kind of operational tools. They need that integration of data. For example, also with the NIPSI team, and with the Cal Fire FRAP team, we were able to integrate the tactical information coming from the GIS edits. We're able to integrate a WRF model of 2-kilometer resolution for 200 hours. That's, I think it improves the HER model both in resolution and in time. That's with a collaboration with ETN. Integration of all the real-time weather information, etc., from weather stations, and we compare the model's performance with the weather station. There are tools for the analysts for that. The new categories of urban, and the validation of that urban encroachment model that Wildfire Analysis uses for doing the impact analysis with the DINS data sets, right? And obviously doing this continuously during the fire season. We have a great collaboration with Google and with Google Earth Engine. So our systems systematically we're using, and it's not the research, it's operational. We're paying for the service with Google, and we are one of the alpha testers in the community that can use Google Earth in production environments to calculate burn scar or to integrate any kind of data for calculating of light fuel moisture model, right? This is just another example of the light fuel moisture dashboard, where we integrate the data of the National Fuel Moisture dataset, and the users can track seasonality. Okay. All right. We also introduced a new exposure analysis, and this was the comment for the paper, and we're teaching the community how to use this for community outreach. And this is, for example, what is the exposure that a community may be facing today before a fire, or during a fire. The fire getting this area here will get in 2 hours. If the fire is here, it gets 6 hours. And actually, we proved that the validation with the touch fire, and we proved that that can happen. Actually, this year, the glass fire was in a very similar condition like that. That's also part of the tool. As also, we have a probabilistic simulations. And in this case, we're running a set of on the hundreds simulations, but we deliver something that is familiar for the advanced, because it's already done with this at a longer strategical scale. We do it in a short term. It's about 1 minute to run about around 100 simulations, some variability on the inputs, mostly the wind conditions and the fuel moistures, and we get those results to start to introduce an uncertainty here, as my friend Mark Castellano always pushes. Not everything is deterministic. Last thing that I will say is that to support all of this, as important as the tools are, is as transferring to the users, empower the users with the training, and transferring for them. Because to be honest, in just 2 or 3 months, those users are going to know much more than us, and they are going to be able to support us to create the next generation of tools, right? So we have a full training module that is defined exactly as the NWCG standard. We have the 101 till the 106. We also have some courses for the tactical analysis web, so the users go through the training, qualifications, and certifications of their understanding of all the topics. It's really critical for us, and in that regard, I must say that Cal Fire has done a great investment. Really, Cal Fire didn't get only you get the tools and that's it. No. The most important is all the 24. Research data specialists that Cal Fire has hired to support the units with these kind of tools. I think that's commitment, right? With the eggs, the pigs, the chicken, and the bacon. Okay, you put 24 people that their work is to use and help in the units and create a community that it takes benefits of these tools. I think is the way to go. Some results, as I mentioned. This first season was absolutely unprecedented. This is a reconstruction that is done with Wildfire Analysis. We can just get all the hotspots from the satellite, and we can create these animatic animations of all the incidents with the reconstruction coming from the VIRRS. Starting in the lighting complex in August, we had the worst fire season in terms of severity and size, 4 million acres, 4.2. In this from August to the end of the year, and I must say that we still have fire season open to the last week. Okay, so we have integrated all these tools, and actually we were able to be there. So we were able to integrate. This is the integration of both the FireGuard plus the VIRRS together in Wildfire Analysis. I think it really gives a really pretty unique way to understand what's going on. Actually, we had some meetings on site, and we got the feedback from the Alaska team and from the EDVAN on site. In the team, Jeff Shelton from Orange County, he told us, okay, this was really useful to show and to tell everybody what was going on with the fire. When you have a fire like this fire, our first giga fire in California, 1 million acres, there's only one way to see it, is through these tools. And we provide the tools to create this inside the tool, okay? And some other examples is the VIRRS fire, the North Fire complex. That was when we got the data and the information. Actually, the run that did this on this fire in September 8th and 9th was absolutely dramatic. And well, we know that wind-driven fires, we know them pretty well. We know what we don't know. We know that we cannot simulate like this the creek fire or the car fire, but some of them, they really perform very well. No? Like for example, I think I have some other one here. That was the Mountain Valley fire. All right. Here we have the integration of the winds and the observation of the fire. And in this case, we have the also automatic dispatch. We get this in 10 seconds, and this is what was accessible for the units in 10 seconds. And that was 4 hours after. That was what the fire guard was telling us what the fire was doing. It's a pretty good ballpark for a 10 seconds analysis, right? So obviously we have good lesson learned for the good and for the bad, but definitely we have a great examples. So we're running, we have more than 300 of these fires being individually analyzed and growing. But I must say that our biggest challenge right now, I would say there are two. One is the right location of the fire, which is coming from the CAD, which is terrible in general, sorry, but it's, I know that the CAD guys, they have to put the fire on the system and then everything starts to roll, but then that fire location just remains. And thanks to the fire guard, we know where the fire is right now, or with the guys coming for the mobile, but it's been pretty, we cannot model properly an initial attack fire if we have a 3, 4, 5 miles errors in the CAD, right? So that is improving dramatically. Also, as I mentioned, some of the results, how can we test that we are analyzing risk properly? Okay, what is the fire activity that day? And the best way to see the fire activity in one day is not the fire perimeters because they're typically delayed. We have a source, which is the VIRRS active hotspots. Well, we match the 90th, this is the 90th percentile of the fire size potential, and and this is the active hotspots on those days. So we are really happy that we were able to produce in advance the values that some peak events, and especially the event that we have in September was absolutely off the roof. Was an event that came after the August lightning event. It was terrible. Okay. All right. So just to finalize on the presentation, let's see if we have a little time for them on questions. We have this question. Can wildland fire tools be modernized and delivered through iterative approaches with fire practitioners and technologies? I think that, yeah, I think that the answer is yes. And I'm really absolutely thankful to Matt Jolly and Brett Ballard for their effort on being able to work with us and make a joint venture agreement. This is the first time that the FireLab does it with a commercial entity to try to advance and answer that question. What can we do tools that could really support fire practitioners, fire scientists and technologies? Okay, well, I think we are on the right path and absolutely thrilled and thankful, as I think all the worldwide community is, as I mentioned at the beginning, for the talent, for the innovation, and for the generosity of the lab that during these 55 years of existence has been opening the science to the world and breaking new grounds and, you know, helping us to understand this really young science and working as the best partner possible. So thanks a lot. I think I'm gonna just make set up a little, I don't know, I think I know how we're in time, because I could do a little live demo while we're talking, but I could definitely entertain some questions while I'm showing the platform.
Thanks, Joaquin. Yeah, we've got 10 or so minutes for questions. So if you want to maybe start a demo, looks like you're doing that now, we can wait for some questions to come in. If people have questions, they can either enter them into the chat box, or you can just unmute yourself and just, you know, ask your question. That is fine too. So we'll give it a couple seconds here for some questions to come in. And Joaquin, if you want to walk us through your demo while we're waiting, that's good.
Okay. So this is, as I mentioned, you've seen now before, this is the interface that we have for Wildfire Analysis. This is the model that we're running. As I mentioned, it's a 2 kilometers model. It's 100 hours. We have the different variables: wind speed, 1 hour field moisture, 10 hours field moisture, the Woody model, all the ones that are needed for running the actual model that we have here. Based on that, we run the FireCast every day. So let me get one of the variables for the FireCast. For example, let's say the fire size potential. And just interrupt me if you have a question. So this is the fire size potential for this hour. It's the number of acres of fires starting at this time with that 8 hours run. That's the potential, no suppression included, right? So that's for every hour. We do it statewide, or we do it by every unit, right? Actually, that was the day. You see the hold here? That's because we already have updated the fuels, right, for those days. That was in November. So those fires, actually, some of those fires, like the Great Fire, was already running. We already updated that. I think that is absolutely critical. Right.
So Joaquin, I might interrupt you here for just a second. There are a couple of questions in the chat box. There's one, is the software available to everyone? Where can it be downloaded?
No, the software is available to anyone that has a subscription. It works on subscription base, and right now here in the US is used by Cal Fire. But if it's a research institution, we can definitely always. But it's a paid software. It's not free. It's not free software. That's the question.
There's a related question asking about the cost of wildfire analyst, and if anyone in the Forest Service has plans to do any sort of bulk licensing or anything like that. Do you want to talk about that for a second, Joaquin?
Yeah, obviously we'd love to do that. I think that this tool fills a gap. That the reason that we did these tools at the beginning, we thought that there was a need of operational fire behavior modeling. I think that the actual tools that were in the lab were never intended like that. I think between Farsight and FlatMap and Behave and all of this in the middle, I think that there was a need. That's the reason we did Wildfire Analysis Desktop. And obviously we love to work with the FireLab. Actually, with the US Forest Service, we have provided licenses to the region in California, to Region 5. So they've been using it in the GACs, and several advanced have been using it. So yeah, we'd love to, obviously.
Okay, we got another couple questions here. I'm curious about the fuel mapping products you're producing from multiple data sources. Are they available to managers in California? And how are you handling updating those data after fires and other disturbances?
Yeah, very good question. So right now, that is a paid subscription that they have the utilities in California. It is not our data. Now it's the data. They can do whatever they do with that. And obviously, for example, San Diego Electric has already provided it to Cal Fire. So yeah, I think that will be available through that side, through the owner. But right now, it's the utilities. That's what we're doing. And there are plenty of different sources of data, as I mentioned. Some of them are a little more time-consuming in terms of processing, like LiDAR-based, and some others not that much. So right now we're working a lot with Sentinel. It's probably our best source, and GDI. GDI is a LiDAR satellite LiDAR that is working really very nicely in terms of updating. Yeah, I don't know if that answered the question. I'm trying to do two things at the same time, and that's something that only my wife can do. I cannot do that. I tried to.
We've got a couple more questions coming in. Joaquin, is it okay if I just keep reading through these questions in the chat box?
Yeah, sure. I'm going to run some simulations. I'm going to spend just basically, I just say that for the audience, I'm clicking on the terrain. So we have the weather, conditions, and the weather observed. We have the soil moisture values. We have the risk values, and that point that I'm clicking. But yeah, go ahead with the question. I'm going to run a simulation here.
Okay, Karen Short's asking if you can capture more accurate ignition location information than the CAD might have you considered passing that information back through to Irwin? I'm thinking about the multiple ignitions associated with each of the complexes this year. The interagency fire data community is struggling a bit with this issue.
Karen, it's a big question, and I know that you have to battle with that. The reality is that we can author that information through fire response. That actually, if one of our users just set up the location on that point, they could update that information of the fire immediately, right? The reality is that then there is the complexity, of the politics on the fire ignition location. So I think there are two things. One is the initial location on the CAD, and then we have what the fire is. And I think that we really need the information what the fire is. So we can keep the initial CAD location. Actually, they can update it if they want, but what we have to provide from the field is just give me what the fire is, or with all these mobile tools. That's what I think that is going to evolve, probably a workflow that is going to evolve on the dispatching centers. So the CAD guys, which have terrible CAD tools in terms for GIS, could update that, or maybe then, or maybe the GIS specialist, right? I don't know the answer to that, but that's obviously the more that we have tools on the field, the better, the closer we are to have accurate initial location information. In any case, National Guard is going to be extended, it seems, for the whole nation. So that information is going to be there for the major incidents, right? But then we have also sources of data like lighting, other sources of, yeah, it requires a little work.
Okay, Greg Dillon is asking, are your fuel mapping efforts connected at all with the California Force Observatory effort, or are they independent?
They're independent. They're independent. We started this work of fuels mapping in 2013 with Camp Pendleton. Then we did the Angeles and the Cleveland. Then we did the San Diego, and then we started to work 2 years ago with the utilities. And California Forest Observatory is a parallel effort. It's different. It's funded by a foundation. We're funded by the utilities, and we're just getting the experience. Our experience, our methods are a little different. We use similar data, but the methods are different, and I think the results are different.
Okay, we've got another question in the chat from Kim Ernstrom. She's asking if it's possible to access some of the training prior to purchasing to try it out.
Yeah, it is. Yeah, it is definitely possible. It's a Moodle campus, so yeah, it's definitely possible. Mm-hmm. And opening a report of a simulation while we're talking. Yeah, keep it coming. This is the report of the simulation. You get it immediately. You get this in 10 seconds, right? All the impacts. Also, I don't wanna forget. Yeah.
So we still have a few minutes here. If people want to type in some other questions or just unmute yourself and ask a question, that's fine too. Looks like Karen had another comment in the chat box. She says, if folks wanted to see your progression animation for the August complex, for example, is that something that would be accessible? Again, thinking about capturing information about the 35 plus ignition sources.
Yeah, definitely. Actually, let me see if I can. I think I can demo that probably. I don't know if I can do everything, but at least I'm gonna get that data from the FireCast. Okay, I think I have to close some other things here, but the answer is yes. And actually, all these animations we can make it accessible for you guys. It's really, yeah, it's definitely really accessible. Yes, the answer is yes. So I'm gonna show how we make one. For example, these are all the FireCast individual perimeters. Let's see if I have one from the Mountain Valley, the Mountain View Fire. There you go, that's here. So we have animated, I think that we have animated in time.
Joaquin, we lost your screen share, buddy.
Oh, I can still see it. Are other people having issues with the screen share?
I can see it.
Can you see it?
Okay, Matt, maybe it's a problem on your end.
Oh, man. Well, I'll tell you later. Okay. So this is anything that you have on the screen. You can just right click. Oh, sorry, I forgot that this is 3D. Okay, let's go ahead. Get it, draw it, and get an animation of that fire. It works exactly the same for the hotspots. I mean, show you the hotspot analysis is exactly the same. Just export the hotspots all together in one piece. There you go. And yeah, and also, I don't know if I have something. I think that's something that is pretty cool. Recently, it's all the work here with the drone imagery. and the aerial imagery. I have a couple of examples. This Claremont, that's the VIRRS complex actually. Let me turn on the GPS units. These are all the GPS units from Cal Fire. That's right now. That's actually right now where they are. Okay. So let me follow the plane. There you go. Here you are. And let me put the imagery. All right. So let's hit on play. So it seems that we have a spot here. So what I can do is, okay, where's this spot? Click and click. As you can see, those spots are here, right? Or, oh, what about this road? Okay, I can click in the map, but also that would also appear on the image. And that's pretty. In the end, it's make things natural and easy, because the interpretation from this to the map, I was always looking at how people was using the imagery. I said, okay, it's a little not very trivial. So that's our job, right? As technologists, let's make things easy, right? I can fast forward on this.
So Joaquin, I'll just jump in here real quick. I think we're right at the top of the hour, so probably can wrap it up here in the next minute or so.
Yeah.
If that works. I don't see any other questions in the chat box.
Perfect.
So awesome. Thanks, Joaquin. Thanks for sharing this cool stuff and spending your time with us this morning. I just have one quick announcement about the schedule. So next week we won't have a seminar, but we'll be back here the following Thursday, February 11th, and we'll have Cliff Mass talking about the meteorology of the campfire. And thanks again, Joaquin. We'll see everybody back here in a couple of weeks. Thanks.
Thank you so much. Thanks, everybody. Everybody be safe out there. Thank you. Gracias.